that they are in. Okay, so for us to identify an irrigated area, that means area that is being fed by water in relation to plants. So for vegetation purposes, some areas are being fed by rain. That means during the rainy season, these plants get their water from the rain. And during the dry season, some plants also get water from artificial water, like supplying them water with pipes and maybe from water bodies nearby. And within this concept, when there's when there's a high transpiration within plants, that means the plants are getting water. So when you measure the canopy temperature of the plant, you actually see that it's actually a healthy plant. But if the transpiration is actually low, that means there's a moisture stress which actually let the plant suffer. So the temperature of the plant will increase instead of it decreasing. So having this concept in mind, they have an instrument that's the handheld radiometer, in which they're able to measure the temperature of the canopy of plants to see whether they are healthy or not. If the plant is suffering from moisture stress, the transpiration becomes low, thereby increasing the temperature of the plant. But if the transpiration is very high, the temperature of the plant decreases, meaning that the plant is in a good condition. At larger scale, using the handheld radiometer to go around is actually quite difficult. So that's when the satellite imagery also comes in handy. And with this, we're able to use the Landsat surface temperature to do this measurement. And with that, it's actually going to help us to be able to determine areas whereby irrigation is taking place. So the formula that we see here, that's the delta T, is the formula that actually help us to differentiate between dry land and irrigated croplands. And it's being achieved using the crop canopy temperature and the air temperature. So if you find the difference between the crop canopy temperature and the air temperature, you'll be able to actually identify areas that are irrigated croplands and dry land. So if the delta T is very high, that means that place is actually experiencing less water, so that site is not irrigated. But if the change in T is very low, then that place is actually an irrigated cropland, which is being provided, which is that area is water area from the irrigators around. So that we are going to use within the system to be able to actually identify irrigated cropland from this from the satellite imagery. And through this, these are the various data sets that we would be using. The first one is the land surface reflectance. That's actually going to help us to calculate NDVI. Then we're also going to deal with the Landsat surface temperature. That will help us to actually get our canopy temperature. Then we're also going to rely on the ER5 climate data, air temperature. So that's going to be our air temperature measurement, that's TA. They are going to use the crop marks to actually help us to identify areas that where crops are. Then use the semi-annual Joule median for visualization of the areas. So these are the 5 data sets we'll be using within the system. And through these data sets, we will be able to calculate the land surface temperature, that's the TC, and also the air temperature measurements, that's the TA. So we are going to use that one to differentiate between dry land and cropland. So these are the data sets that we would be using. Then we are going to have study area, that's Upper Sudan, part of Sudan, and also Upper East region section of within Ghana. Okay, so as you see, when we apply the formula, that's using the surface, Landsat surface temperature, and also the ER5 air temperature, when we calculate the difference, you see that within this image, you have the scale from 0 to 22.5. That's all in temperature. And what we can see from here is that areas with lower values, that's below 10, are areas that are actually experiencing a form of irrigation that is ongoing. And areas with high, that's high change in T, are areas that are mostly, we will classify them as cropland. So this is for the area that we are working in. And from here, the next thing that we did was to actually get a concrete evidence that the areas that the change in T classified as irrigated areas, are they truly irrigated areas, or is maybe in the form of another, or maybe another interference is actually making it get those higher values, lower values. What we did was also to generate the NDVI for the area, then use the K-mean clustering to do machine learning algorithm to actually see the areas that actually corresponded to the irrigated area. So from the what you can see is, from the left side is the temperature, that's a change in T in degrees Celsius, and then on the x-axis is in the NDVI. So the higher the NDVI and the lower the change in delta T are classified as irrigated, and those that have lower NDVI but higher change in delta T is classified as dryland. So having these two concepts is actually able to help us to differentiate between the irrigated areas and dryland. Really depending on the change in T, but also we also want to make it more more interesting. So they use the NDVI also to it. Then from there, what you can see is just the end results. The first one is the draw median of the area that we are working on. And as you can see, the top section is actually more of dry land, and the down section is cropland areas. So using the system, you're able to classify that, okay, on the left side of the land area, it's mostly irrigated areas, and on the right hand side, areas are irrigated and other areas are not irrigated. So it actually gives you a clear idea to identify the areas that are being irrigated. And this is also for Ghana, a certain part in the Upper West region. As you can see, higher change in T, that's delta T, results in less, that means more dry land over one. From the K-mean clustering, you're able to actually identify the number of areas that are the points, number of points that falls within the irrigated areas, and the point that also falls within the non-irrigated. As you can see, within the Upper East region also, a lot of areas also have this irrigated farming going on within those areas. So with this particular work that we are doing, it's actually purely based on assumption. That means we are using the temperature that's being approximated by the ER5, and also the land temperature that's also being approximated by the Landsat 8 surface reflectance. So we are actually using these two variables to determine the change in T. Also, with this particular notebook or with this particular algorithm, it actually works for dry period, that's dry season, instead of wet season. So if you run this notebook in areas where there is rainy season, the results that you are going to get won't be a 9, because there is rainy season, there are a lot of green appearing. That means the plant is having less, more transpiration, so less, the temperature of the plants drops. But if you are doing it in a dry season, it actually helps you to identify irrigated areas which is not fed by rain, but rather man-made. And also in cold times, also if you try to use it, because the moisture stress, it will also have a problem and it can also affect the change in T. So when using this method, it's good to always try and work during the dry period for that particular area that you are working to actually get the good results. And one of the things also that also make it much more interesting is to have a validated data with you, so that the result that you are going to get, you'll be able to show, you'll be able to use it to compare with what you already have to actually get it. This notebook has been written, but it hasn't been tested, so you'll be happy that you'll be able to test it out, especially with areas that you already know that those areas have there's irrigation ongoing there. The notebook can be found in the real world example, that's the irrigated cropping notebook, or by clicking on the link, it will actually send you to that area. So these were the references that we used to be able to generate the re-examination of the crop water stress index for the area. Thank you for the presentation. So right now I will change my screen. Then I'll go straight to the notebook where you will have the chance to go through the notebook one by one and see how it actually works. Okay. Open my sandbox. Okay, so this is the sandbox. So if you log on to your notebook and you pick the, you log on to it, you choose the real world example folders. Inside it, you are going to see the notebook called irrigated cropping. Before I go through the notebook, before you go through the notebook step by step, speak, is there any questions for me on the slide? And also, I'll be happy if you can also give me an area of interest within the chart, whereby after going through the notebook, we also run that in for that particular area of interest. By providing the latitude and longitude for that particular area, then just run you just run it for that particular area to see the results that you would get. Then if no question, then let me move straight into the notebook. So the notebook is titled Identifying Active Irrigated Cropping. And just as I explained, the data sets that we are using is the year 5, the surface temperature, and also the surface reflectance, and the semi-geomedian. So the first step is to load your basic functions that you need. Then at this section is where you specify the latitude and the longitude of the area that you want to work with. So you specify the latitude and the longitude and the area. And the time period also, you have to mainly specify within the dry season period so that you can actually get good results of the area that you're working in. Then we display the image also. Then you load the surface temperature. So after loading the surface temperature, the Landsat surface temperature is in Kelvin. So you have to convert it to Celsius. So this session actually converted to Celsius and resample it. So what you see is the surface temperature for that particular area of interest within the Upper East region. Then the next step is to load the ER5 temperature, which is the air temperature at 2 meters above the surface. And that because that one is an hourly data, we will resample it to monthly data. Then after that, we also plot that one out to make sure that the area falls within the area where our image is also falling. Then from there, you will calculate the change in the surface temperature. So the delta T is where we calculate the change in the surface temperature and the ER5 air temperature. Then the result is being plotted out from here. So as you can see, areas with higher values are mostly dryland areas, and areas with lower values are areas with water. That means the delta T is very low within those areas. So as you can see, where my mouse is moving, you notice that because that side is actually water, it's actually at a low value for that particular area. Then the next thing is to load the surface reflectance. For the surface reflectance, the main reason why we are loading is to actually calculate the NDVI for that particular area you are working with. So as you can see, we calculate the NDVI. Then we use the crop mass to max out only the cropland areas within those areas. Please mind you, at this session where we have the load crop max, depending on the area that you are working, if you are working in the northern, that means the crop mass should be crop mass underscore northern. If you are working in the Sahel, the western will change to Sahel. If you are working within the southern side also, it also change to southern side. So the good news is that right now you have the crop mass for the whole of Africa, and it's available within the map session. So if you go to the map session, let me go to the map session, then you go to the explore map, then you go to agriculture. You see that right now you have the Eastern, West Africa, Sahel, Southern, South, Indian Ocean, and Northern Africa all available. So if you click on them, the respective name will come up for you to see. So please, within the notebook, when you reach this crop mass, make sure that the crop mass actually falls within the region that you are working in. Otherwise, you'll get an error there. And I'll just show you very soon on some of the errors that you can do. So after identifying the NDVI of the area, start for classification, whereby we are going to work with both the delta T and the NDVI to be able to actually help us to know where the irrigation and the dry lands actually fall. So as you can see, we have it here showing at that section. So actually help you to get the confidence within the data that you are having. So after that, the system will automatically plot it for you to see this result. So at the end of the day, you are able to identify areas that are irrigated from the notebook. So that's how the notebook actually works. Within the chart, someone can has posted an Egypt crop plan. So we are going to put that one there within the latitude, which we are supposed to change 22.620015. Then the other one is going to be 28.643029. So let's run this one. So I click on Restart Canal and run it all. So to restart the kernel, then it will run it all for the area that you are working within. So because this area is Egypt, well, let's see whether I'm in the correct area. Am I in the correct area? Yeah, I think so. Okay, let's go down to see if you're in the correct area. Interesting. Getting nice data there. So you can see we're having low values, but not that low for some areas, and it's being run. Ken?
I think the coordinates might have not been there.
Yeah. Yeah, I think we are in the desert. This is Egypt. Let's go there. See. There's another question. Hey, look, can you run an example on the upper east region of Ghana after this, please? Oh, yes, you can do that. You can do that. But we'll be happy if you can get a coordinate of a particular area from the coordinates that we just presented, if you look at the NDVI, you notice that is 0. That means nothing is actually happening within these areas. Okay, so upper west coordinates there. Let's do that and see. So the latitude is 9.9. The longitude is -2.5. Okay, so yeah, I've gotten this. Then let's restart and run off for that particular area. Because you're using a smaller area, it will, for this demonstration purpose, to be able to run fast. All right. We are in Gabon. Okay. Did I change something? Okay, let me change this one. Okay, so we are in Upper East now. Let's restart and run or because you are in the Western region, because you are still in the West Africa, you will still maintain the crop underscore maps within the Western. If we are supposed to do with the Egypt's own, you would have changed the site to Northern because Egypt is within the Northern Africa area. This is the mean land surface for the area of interest that we just ran. They also ran the, so this is the delta T. So as you can see, where we have the green areas, it's more of a crop land because the temperature of the crops is very low. That's why you are seeing the green areas within those areas. So from here, you get the NDVI, then max the crop land out for those areas. So see where you have the irrigated and the points, and voila. As you can see, the yellow areas are areas that are irrigated farm areas from the system. So this is level, and you can go in, play with it, tweak the values, change the study area to see how the system will bring out the irrigated areas. Then if you have a validation data also, you can add it to it for us to see the validated area for those area of interest also. So I'm going to run the last area for Egypt. Please, can you, if you have any question, you could ask.
Hello.
Yes, Houston. Hello.
Sorry, it was the afternoon. Sorry, I joined a bit late. I can see that you did like some NDVI analysis, and I wanted to ask if you could also do like a soil adjusted vegetation index analysis as well, because I found by literature that's the more accurate method. I don't know if you could do that one here as well. Thank you.
Yes, you could do that one also. Once you have the indices and you have the data sets, that one can also be implemented. So is it the M survey?
Yeah, the survey, soil
Yes.
adjusted vegetation index.
Yes, so that one can also.
Wow, I know it can be done, but I'm like, can you do it here now? Let's see if the there is like a difference between, you know,
Oh, okay.
NDVI and the other one. Yeah.
Okay, so before that, okay, perfect. Let me run this. Let me run this one. Then after that, I will check the indices, whether we have that one inside, then I'll run that one as soon as possible. So because we are dealing with the southern sector, the northern Africa, we're going to change the name here. We will change the name here to northern. Then we will execute it. So while we are executing it, I want to check an index to see whether it's available so that it will make our work much more easier.
Okay.
Yeah, I want to check if it is there, then that means to make the work more easier for us. Otherwise, the survey, right?
Yes. Yes. Correct.
Okay. So once the survey is there, we'll just pick it up. Then once this one is done, you run that side also. Oh, voila. So as you can see, you have these 9 crop lands there. And all these are irrigated lands. That's how you can see the yellow marking them for us to identify these irrigated areas. So right now, the next step is we want to use the NDVI instead of using the survey. So to use a different index, you come to the section, then you change the NDVI to survey. The SAVI survey there. And we have to make sure that wherever we see NDVI, are going to put the survey there. Otherwise, we will run into an error. So you have to go through the notebooks and
Okay.
wherever you see NDVI, you place it with survey. Otherwise, you will run into an error when executing it. Okay, let's see. Okay, so let's run it. If an NDVI error pops up, we would just hit that at that area and see the results. So we are running it still for the Egypt area, but this time instead of using the NDVI to help the Delta T, we are going to work with the survey to assist us or to also help us to identify these irrigated areas. The Delta T is actually doing a great work here. Okay. So this is the survey for the area. So the cropland area. So we have the irrigated compared with the survey. So it is not the NDVI, this is the survey. I didn't change it here.
Okay, I can see that. It's fine.
Yeah. So this is also the results using the survey to do the classification.
I think it's more robust than the initial I don't know, calculation.
Yes,
Like
yes.
It has more results, yeah.
Yep. So I think we can do a more comparison to see which of the indices works right for the area that we are there. Then we will stick to that, and we will be happy it for those years and share it with us also, with the whole community for people to also use it. Okay, so this is where my presentation will end. Thank you, everybody. If there's any other questions, we are available to ask. If you need further support on how to work on to use this notebook, please you can reach out to us, either Ken or I. We are available. Then we will support you in within any area that you want to work.